Buried within the concrete jungle, hidden from plain sight, lies a network of steel that holds our world together. This is rebar, the unsung hero of construction. Rebar might not have the outward appeal of gleaming skyscrapers or majestic bridges, but it plays a crucial role in their very existence. Without rebar, our built environment would be a shadow of its current self. This is the story of rebar, a journey from humble raw materials to the backbone of modern civilization. Rebar, short for reinforcing bar, is essentially steel designed to reinforce concrete. Concrete, while strong under compression, is weak under tension. Rebar, with its high tensile strength, compensates for this weakness. The two materials work in tandem, creating a composite material capable of withstanding the immense forces present in buildings and infrastructure. The journey of rebar begins long before it reaches a construction site. It starts with raw materials, primarily iron ore, which is found in abundance around the world. Iron ore is the foundation upon which the entire process is built. Iron ore, mined from the earth, is the primary ingredient in steel. This raw material begins its journey with extraction from mines. The ore is transported to steel mills for processing. At the mill, impurities are removed and iron is extracted. The ore is crushed into a fine powder. The powder is fed into a blast furnace. Inside, a fiery transformation occurs. Coke, derived from coal, generates intense heat. This heat, along with limestone, melts the ore. Molten iron is collected at the furnace base. It is then refined in a basic oxygen furnace. Oxygen is blown in to remove remaining impurities. The molten steel, a glowing testament to the intense heat and pressure it has endured, is now ready for its next transformation. This stage, often considered the heart of the rebar production process, involves shaping the molten steel into its characteristic form. This is where the journey from liquid metal to solid construction material truly begins. The molten steel, still at a scorching temperature, is carefully poured into a continuous casting machine. This marvel of engineering, often spanning hundreds of feet, is where the magic of shaping takes place. The molten steel enters the casting machine through a water-cooled mold. As the molten steel comes into contact with the cool mold, it begins to solidify. The mold, continuously moving, gradually shapes the steel into a long, rectangular shape known as a billet. The billet, now solid but still extremely hot, is cut into specific lengths using high-pressure water jets. These billets, glowing orange from the residual heat, are then transported to the rolling mill. This is where the transformation from a simple rectangular shape to the familiar ribbed bars of rebar takes place. Section 4. Shaping the strength, rolling, and forming. The rolling mill, a symphony of heavy machinery and clanging metal, is where the billets undergo their final transformation into rebar. Here, the billets are reheated to a specific temperature to increase their malleability, making them easier to shape. The reheated billets are then passed through a series of rollers. These rollers, carefully calibrated to apply precise amounts of pressure, gradually reduce the thickness of the billet while elongating it. This process, repeated multiple times with progressively smaller rollers, shapes the billet into the long, cylindrical form of rebar. During the rolling process, the distinctive ribs that give rebar its name are imprinted onto the surface of the bars. These ribs, strategically designed to enhance the bond between the rebar and the concrete, are crucial for the structural integrity of reinforced concrete structures. The now formed rebar, still hot from the rolling process, is then cooled under controlled conditions to ensure its strength and prevent warping. Once cooled, the rebar is cut to specific lengths, ready for its final destination: construction sites around the world. Section 5. The essence of strength. Rebar's role in construction. Rebar, the unsung hero of construction, plays a vital role in ensuring the strength and longevity of our built environment. Its importance stems from its ability to compensate for the inherent weakness of concrete under tension. Concrete, while incredibly strong under compression, meaning it can withstand immense weight pushing down on it, is relatively weak under tension, or forces that pull it apart. This is where rebar comes in. Embedded within the concrete, rebar acts as a tensile reinforcement, absorbing and distributing tensile stresses that the concrete alone cannot handle. This synergistic relationship between concrete and rebar forms the basis of reinforced concrete. a material that has revolutionized the construction industry. Reinforced concrete, thanks to the combined strength of its constituent materials, allows for the construction of taller, stronger, and more durable structures. From towering skyscrapers that pierce the clouds to sprawling bridges that span vast rivers, rebar plays a silent but essential role in shaping our world. Section 6. Conclusion. A testament to strength and durability. The journey of rebar, from its humble origins as iron ore to its crucial role in our built environment, is a testament to human ingenuity and the transformative power of engineering. This often overlooked material, hidden beneath layers of concrete, is a silent guardian of our cities and infrastructure. Next time you marvel at a towering skyscraper or cross a majestic bridge, take a moment to appreciate the hidden strength within. Remember the rebar, the unsung hero that makes these feats of engineering possible. It is a testament to the fact that true strength often lies in the unseen, in the materials that work tirelessly behind the scenes to hold our world together.